So this is the homework for the soundwave simulation, and it says here I have to do a single score source tab in soundwaves. Start your investigation of sound and turn on the audio enabled. Okay, so it says here I have to choose the frequency and the sound change. Okay, I'm gonna turn it on. So as we can see here, originally the person this is giving me a headache. But as you can see, the person is I'm in speaker. I'm in regular speaker, so as you can see, it's just a speaker. However, we're gonna go to listener, and what we're gonna do first is we're gonna change the frequency. And if we change the frequency, let's see what happens. So as we can see that the frequency gets higher over time. But if we go back to 500 newtons, like around there, then we can see that the visual model is actually just a ripple effect. Then the changing the amplitude, if we're gonna do that, let's do that. Ooh, it's almost here, and so it's a lot higher. Amplitude is basically like a speaker. As I was saying, it's just amplitude. So amplitude is basically the sound on its model. It's like a speaker where if you go far, you can hear it from over distant time, and when you get closer, you start hearing the sound. Here, number 2 is sound is produced when something vibrates, movement causes disturbances. Like I said this earlier, like if you try moving the hair back and forth, I really don't like hearing this. But if you go back and forth, we can see that as you go closer towards the speaker where the waves show, we can see that the waves have more of a potential, or like more rippling effect, because you're getting closer towards the speaker, and so there's more wind particles going against each other, rather than out here where there's less. Number 3, use the tools to that's giving me a headache. And use the most measure tab. Okay, I'm here gonna go to the measure tab. If you're gonna go to measure tab, and we're gonna go here. I don't understand what's this for. We can see it's 5 meters. So and you have a good experiential calculations. You have good. Excuse me. I don't believe that Mr. Day gave us specific kind of equations, because you just given me this stuff today, just today, and I have no idea what the heck are we doing. So at most, what I'm going to be doing is explaining these. So if you go to audio enabled, we can see that the hertz or the person here is gonna hit. Yeah, it's just me playing around. But this part is the weirdest part. Because over here, we can see here that the waves are intertwining, so there's not a lot of. See that the waves here are less of a sound, but if you go to each one of the sounds, they're yeah, basically anything on their diagonals shows that they're going side by side, that the sound will somehow reduce. Now if we can go here and see that the lower angle, um, we can see that as we go farther and farther away, yeah, that's fun. We can see that it's just gonna go back and forth, and that's how we can hear stuff when we go to just like a giant room or a small room, because the sound waves don't have to ripple out from each other as far as to compared to a person in a large room. So it'll take more. I'm gonna do an example of a person inside a small room. If it's a person inside a small room, you can hear each other much more clearly because the rooms are a lot more. Like, let's just say like here, they're more close. However, if it's a large room, we have more of a bigger sound or bigger sound effects here, and the amplitude even bigger. Even if the frequency is higher, it takes forever to get the waves out. And here uh, for varying pressure, air density is since its waves is also rippling effects. We can see that the particles of the air are being moved. So if you take out the air particles, and we can hear over time, as we can see the pressure is moving up, no more pressure. We can hear that the sound inside or the air particles are not going to be there anymore. It's not gonna store. It's not gonna show there. What all of this means is that they need the air for us to we need air for us to hear something, so that it can show a ripple effect. So if we add air to the box, we can see that over time that the ripple effects will again show it to the speaker because it's on the listener. And almost there, yeah, like right here, we can see that we can hear that the ripple effects are starting to show each other and make it a lot louder because we depend also on air particles. I mean, and that's it. See you guys.